Hello and welcome back to For Knowledge. In today's session, we are going to discuss about determinants, how to calculate determinants. So first of all, what is a determinant? A determinant is nothing but a scalar value or a real value associated to a square matrix. That means if you are having a square matrix, what is a square matrix? Square matrix means a matrix where the number of rows and columns are equal. So suppose this is a square matrix A, B, C, D. Now, if we can associate a real number or a scalar value, suppose some alpha, okay, we are associating alpha to this matrix, square matrix, in some certain way, or technique, then this alpha is the determinant of this matrix. Okay, so determinants is nothing but an association of a real number to a square matrix. Fine. Now the next question comes, how we associate the value. There is a technique that I have already mentioned. So we are going to learn how to calculate this alpha. Okay, how to calculate this alpha. Now in the beginning, let us start with the smallest square matrix, that is, suppose A is a smallest square matrix, that is 1. Why this is a square matrix? Because it has a single row and a single column. So this is a square matrix. This is the smallest square matrix, 1 cross 1. First single row, single column. Fine. So determinant of A is nothing but the value itself, that is 1. Fine. This is the determinant value for a 1 cross 1 square matrix. Okay. Now if another matrix 3, this is also a 1 cross 1 matrix, 1 cross 1 square matrix. So determinant B will be 3. Just like that. Fine. So now let's move on to a 2 cross 2 square matrix and how to calculate it. Suppose A is equal to 2, 3, 4, 5. Now it is a 2 cross 2 square matrix. Fine. It is a 2 cross 2 square matrix, 2 rows and 2 columns. Fine. So now how to find that alpha? What is alpha? Suppose we are saying that determinant A equal to alpha. Now how to calculate the alpha? What is the methodology? So determinant A, very simple. The technique is very simple for 2 cross 2 matrix. Just multiply the elements diagonally. That is 2 into 5 and 4 into 3. Subtract them. So 10 minus 4 into 3, 12. This is minus 2. Got it? Another one. Let's take another one. 1, 0, 3, 4. What is determinant B? Very simple. Diagonally multiply the elements. 1 into 4. 3 into 0. Subtract them. 4 minus 0, that is 4. Now the question comes, which one should I do first? Whether this 2 into 5 or this 4 into 3. The rule says go with the diagonal elements, principal diagonal elements. Okay, go with the principal diagonal elements. What are the principal diagonal elements? This one. Okay, 1 1 and 2 2. This one 1 1 and 2 2. In this case, this 1 4. First multiply 1 and 4. That means the elements in the principal diagonal. Then multiply the elements in the off diagonals. Okay. So principal diagonal minus 3 into 0. That is 4 minus 0. that is 4. Okay, that's how we multiply a 2 cross 2 matrix. Fine. Now let's move on to a 3 cross 3 square matrix. How to find the determinant of a 3 cross 3 square matrix, because if it is not a square matrix we cannot find the value of the determinant of the matrix. Okay, so now let's consider A equal to 1 2 3 4 5 6 7 8 9. This is a matrix of order 3 rows 3 columns of order 3 cross 3. Fine. Now we have to calculate determinant A. It's not that simple. It's not that simple. The one we have done in the case of 2 cross 2 matrix. So understand the matter. First, you have to select a single row or a single column in the beginning. Suppose we are considering the first row. So if we are about to calculate the determinant along first row, then the formula will be the element 1 into cofactor of 1 plus the element 2 into cofactor of 2 plus 3 into cofactor of 3. Fine. If you are to calculate along column 2, then what will be the formula? Then determinant A will be 2 into cofactor of 2 plus 5 into cofactor of 5 plus 8 into cofactor of 8. You can consider any row, any column. And you can calculate the determinant. Suppose you are about to calculate the determinant along 7 8 9. So the determinant A will be 7 into cofactor of 7, 8 into cofactor of 8, 9 into cofactor of 9. Okay, but remember one thing, do not mix up the rows and columns. Okay, suppose you are starting with this 1 into cofactor of 1, then you move on to the second row, that is 5 into cofactor of 5, then you add 6 into cofactor of 6, then you won't get the result. Okay, you have to stick to a single row or single column and apply this formula. If the element is A, B, C in a single row, then the determinant will be A into cofactor of A plus B into cofactor of B plus C into cofactor of C. That's the basic thing. Okay, do not mess up with rows and columns. Stick to single row or single column. I hope you get this. Now, what is cofactor? What is cofactor? Cofactor we are going to learn next, because unless we learn what is cofactor, we cannot proceed with this. So copy this. So let me erase this. We are going to find the cofactors. Okay. I am taking a random example, not this one. Okay. Suppose there is this matrix 2 3 rather let's not let's A B C D E F G H I. Okay, we can find the cofactor of each and every element. Okay, we can find the cofactor of each and every element. Fine. So what is cofactor of A? Cofactor of A, this one. How to find cofactor? Just eliminate the row and the column where A is present. Eliminate the row and the column where A is present. Consider this subdeterminant EFHI. Okay, so the leftover terms is EFHI. So this is nothing but this subdeterminant EFHI. Along with that, minus 1 to the power the row plus the column where the element is present. Now A is present at row 1, that is number of row is 1, and column, the number of column is 1. So 1 plus 1. That is the cofactor of A. So what is this? If we simplify, minus 1 to the power 2 into this determinant, it is a 2 plus 2 determinant. We can calculate this first along the principal diagonal, that is E into I minus this one H into F. So minus 1 square is 1, that means EI minus HF. This is the cofactor of A. Now if we are to calculate the cofactor of suppose a D, so cofactor of D equal to minus 1 to the power, what is that? Minus 1 is present at second row and first column. So row number is 2 here plus column number is 1 here, 2 plus 1 into the subdeterminant. Which subdeterminant? D is present at second row and first column. So the leftover subdeterminant is BCHI. Write this down. BCHI. So minus 1 whole cube into B into I minus C into H. That is minus 1 into BI minus CH. That's how we calculate the cofactor of D. Okay. What about cofactor of I? Cofactor of I equal to minus 1 to the power, where is it present? It is present in third row, third column. So minus 1 to the power, row is 3 plus column is 3 into the subdeterminant. Third row, third column will be eliminated. So A, B, D, E. So minus 1 to the power 6 is 1 into AE minus BD. That is how we calculate the cofactor of the element of a matrix. Cofactor can be calculated for each and every element of the matrix. Got it? So now let's move on to the problem. We have to calculate the determinant of A. So determinant of A, I am taking the first row. Okay, I am calculating the determinant of A along the first row. So 1 into cofactor of 1 plus 2 into cofactor of 2 plus 3 into cofactor of 3. Fine. So 1 into, what is cofactor of 1? Let me write the matrix here again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 is present at first row, first column. Okay. So minus 1 into minus 1 to the power. Row number is 1, column number is 1. That is 1 plus 1. Now, which subdeterminant we have to take? Just eliminate where 1 is present. The first row and the first column is eliminated. So 5, 6, 8, 9. Determinant 5, 6, 8, 9 plus 2 into 2 is present at row 1, column 2. Row 1, column 2. So now just 2 into minus 1 to the power first row, second column. First row, second column into the subdeterminant. 2 is present at second column, first row. So eliminate first row and second column. The leftover is 4, 6, 7, 9. 4, 6, 7, 9. I hope you are getting the point. 4, 6, 7, 9. Plus the last one, row 1 and column 3. 3 is present at row 1, column 3. So minus 1 to the power first row plus third column. And the subdeterminant first row, third column. So 4, 5, 7, 8. 4, 5, 7, 8. Calculate. Simple. So my 1 into minus 1 to the power 2, that is 1. 5 into 9, 45, minus 8 into 6, 48. Plus 2 into minus 1 cube, minus 1 cube, minus 1 whole cube. Minus 1 whole cube means minus 1. So minus 2 times 4 into 9, 36, minus 7 into 6, 42. Plus, I have forgot to mention a 3 here. Sorry. This 3 element into cofactor of the element into cofactor of the element. So 3 into minus 1 to the power 1 plus 3, that means minus 1 to the power 4. Minus 1 to the power 4 means 1. So 3 into 1 into 4 into 8, 32, minus 5 into 7, 35. Calculate. Minus 3, 45 minus 48 is minus 3. Minus 2 into, this is minus 6, plus 3 into, this is minus 3. So minus 3 plus minus 2 into minus 6 is minus 12, minus 9. So minus 3, minus 9, minus 12, plus 12, this is 0. Simple? Yes. This is along row 1. Now if we are to calculate along some other row or other column, let us do that. Okay, this is along row 1. I am erasing this. Let us calculate along, suppose column 2. Suppose along column 2. So determinant of A equal to 2 into cofactor of 2 plus 5 into cofactor of 5 plus 8 into cofactor of 8. How? 2 into 2 is present in first row, second column. So minus 1 to the power row number is 1 plus column number is 2 into subdeterminant. Remove first row, second column. So 4, 6, 7, 9 is remaining. Plus 5 into 5 is present at second row, second column. Second row, second column. So minus 1 to the power second row 2 plus second column 2 into subdeterminant. Second row, second column is eliminated. Second row, second column is eliminated. 1, 3, 7, 9. Plus 8 into 8 is present at third row, column 2. column row 3 column 2 minus 1 to the power third row second column into subdeterminant row 3 column 2 is eliminated 1 3 4 6, right? Calculate 2 into minus 1 to the power 1 plus 2 minus 1 whole cube, minus 1 whole cube is minus 1 into subdeterminant 4 into 9 36 minus 7 into 6 42 plus 5 into minus 1 to the power 4 that is 1 minus 1 to the power even power is 1 minus 1 to the power odd power is minus 1. Okay, so minus 1 to the power even, that means 1. So 5 into 1 into subdeterminant 1 into 9 9 minus 7 into 3 21 plus 8 into minus 1 to the power 3 plus 2 5, that is minus 1 to the power odd, that means minus 1 into subdeterminant 1 into 6 6 minus 4 into 3 12. Simplify. So minus 2 into minus 6 plus 5 into minus 12 minus 8 into minus 6. So minus 2 into minus 6 that is 12 minus 5 into minus 12 minus 60 plus minus 8 into minus 6 48. So 12 plus 48 60 minus 60 that is 0. What was the previous result? It was also 0. So irrespective of whatever row or whatever column you are choosing to calculate the determinant, the answer will be same. Okay, there will be no difference at all. Now I am going to give you some assignments, like you calculate the determinant of A along all the other leftover rows and columns. Okay, you have to calculate the determinant of A along all the other leftover rows and columns. I have done along row 1 and column 2. You have to do along row 2, row 3, column 1 and column 3. Okay, and every time you have to get the result, that is the determinant of A is 0. That means that alpha that we have started with, that should be unique to a single matrix. Okay, no matter what, whichever row or whichever column you choose, the alpha won't be different, the alpha should be same. Okay, I hope you understand the video, and if you like the video, then please like and subscribe our channel. Thank you.